Okay, we're starting 9.2, which is intersection, union, and compound inequalities. Okay, so let's get started. 9.2, yeah. Let's share the desktop. All right, so one note, and it's math 125. And let's do a new section. Okay. So, 9.2. Intersections, unions, and compound inequality. Where are the others? At 10:30? What time do you go to bed? Okay. Okay, so you didn't go to bed at night. You went to bed in the morning. Okay, so anyway, let's talk about intersections. Right. So intersection. So the symbol for intersections is a. Oh, sorry. Okay. So intersection is A, intersection B, and the key word later on which you need to remember, intersection is N. Yeah. So A intersection B is the set which contains elements common to both A and B. So both in A and B. So N is the keyword. Yeah. So for example, let's talk about the set of the first 5 natural numbers. The first 5 natural numbers. So I want you to tell me what they are. And then B is the set of the first 5 prime numbers. Oh, the A is also a set. Yeah, the set of the first 5 natural numbers. B is the first 5 prime numbers. So what are the natural numbers? What are the natural numbers? Natural numbers. What are natural numbers? What numbers are natural? How do you count?
1, 2, 3.
Yes, 1, 2, 3, 4, 5. How about 0? Oh, we talked about this, didn't we? Counting numbers, right? Okay, what about prime numbers? What are the, give me the first 5 prime numbers. 4 is prime? 3, 2 is prime, right? Okay, so 1 is not prime. So it starts with 2. 2, 3, 5, 7, how about 9? No, 9 is not prime. Why is 9 not prime? Yeah, it's divisible by 3. Yes? So the numbers that are not prime are called compound numbers. So the first 5 prime numbers are 2, 3, 5, 7, 11. So those are the first 5 prime numbers. Alright? Now, what is A intersection B? So my questions are, which ones of these are common to both A and B? Which one? What else? What are common? 5, okay. 2, 3, okay. Now this is a set notation. The order doesn't matter. Yeah. Alright, so now I could draw my Venn diagram. So let's see. Alright. And then let's see if we can intersect this. Actually, I want to do something else here. No. I want to use this if possible. Alright. So if this is A, and this is B, and the intersection will be in the middle, which is 2, 5, 3. And in A, I have 1 and 4. And in B, I will have 7 and 11. Yeah, so this is called the Venn diagram. And which one is A intersection B? This is the middle. Is A intersection B. All right. So this is A intersection B. So how many times do I write down 2, 5, and 3? Only once. Yeah. Venn diagram. The name is Venn diagram. All right. Okay. Now, how is this related to inequality? So we will talk about n. Okay. Let me see my notes. Are you guys ready? So we all know this, this inequality. X is greater than -2. Do you guys know this inequality? Yes, but then I say n, x is less than 4. All right. So what does it mean? X is greater than -2 and x is less than 4, or less than or equal to 4. So I'm going to change this a little bit. So this is less than or equal to 4. All right. So how do I graph these? Like before, we had this number line. -2, open or close? Open, and the arrow points to the right. Yes. Now remember, when I draw my arrow, what? I need to draw it all the way to the end of the number line. This is important. Yeah. Good. So don't stop in the middle. How about 4? Open or close? Close. And my arrow points to the left. So I'm going to draw it all the way to the end of my number line. So what I meant is I shouldn't have something like this, right? I need it to go all the way to the end of my number line. So not this. Okay? So not stop in the middle like this. Yeah? All right, now let's talk about the conjunction. The word is and here. What does and mean? Remember, and is intersection. So it has to be in both A and B. So for our graph, it just means that the points have 2 lines on top. So which points have 2 lines on top? This is -2. Yeah, so it's from -1. Where did you get -1? -2 to 4. Yes, so this is this one. So you can see that this and it just means it has 2 lines on top. Which points have 2 lines on top? It's between -2 and 4. Yeah. So the answer here, interval notation is -2, 4. All right. So is the bug still there?
Yeah.
What is it called again?
Magnetic.
Magate?
Mayate.
Oh, mayate. What does, okay, what does it do? Nothing?
Just size around.
Oh, okay.
Doesn't bite or anything.
Okay, good. So what happens if it's inside me? Does it mean I will win a lottery or something?
You actually can tie it. I think so string. Yeah, and just slide around.
Oh. It doesn't mean I will win a lottery, right? Super lotto or something. No? No, it was on my, it's in my...
You have ties, you would slide one of these.
Oh, I see. Okay. Okay. Okay, guys. Let's continue. Yeah. Are we okay? Do you know what N means again? Two lines. Yes. Why is it two lines? Because it's intersection. Yeah. The points need to be on the first set and also on the second set. Easy? All right. Now, number two. Oh, a little more. Number two. What about if I have 4 is greater than y and y is greater than or equal to -6? What would you do here first? So 4 is greater than y. What does it mean? So 4 is greater than y. It means what? Y is what? If 4 is greater than y, then y is less than 4. Yes. Yeah. So it just means I usually like to have y to be the variable to be on the left, right? So that's why I rewrote this. Do you have to rewrite it? No, but I like to do it, so that's why I always do it. Now 4, open or close? Open, and the arrow is to the left. Now when I draw the arrow again, I draw it all the way. Yes. 6, -6, open or close? And the arrow is to the right. Now remember, when I make my arrows, they have to be different heights. You see, one is higher than the other. Yeah, different heights. Now I'm going to read my word in the middle. So this is an N. So what does N mean? 2 lines. So which points have 2 lines? -6, 4. Finish. Okay. All right. Now more. Why don't you try this, okay? Number 3. -1 is less than x plus 2 and x minus 4 is less than 3. And then number 4, a plus 4 is less than -1. Okay, and 3a minus 5 is less than 7. Okay. All right. So why don't we try these two? So I'm going to eat my throat medicine, okay? This is a candy. Oh, sorry. Okay, so what are we going to do here? Yes, have x by itself, so we subtract 2, right? So -1 minus 2. Okay, good. And then if negative 3 is less than x, what does it mean? Okay, good. No, the other one. Yes, so when I move negative 4, it becomes plus 4. So 3 plus 4 is 7. Yes. All right. Okay, so negative 3 is open to the right. 7 open to the left. What is my solution? And remember, this is n. What does n mean? 2 lines? Okay. So my solution is negative 3, comma 7. Okay. Does everybody remember the interval notation? When do we use bracket? When do we use parentheses?
Equal to.
Right. Open circle and also infinity and negative infinity. Right? Yeah. Okay. Good. Did you try number 4? Number 4? Okay. So try number 4. Okay, let me give you one more. Number 5. X is greater than 2a minus 1 and negative 4 less than or equal to negative 3a plus 2. Finish? Yes? Finish? Okay, so let's do this one. Number 4. A plus 4 is less than negative 1, so I need A to be by itself. What happens to 4? So negative 1 minus 4 is negative 5, yes. So 3A has to be by itself. You move 5 to the other side, so 7 plus 5? 12. Okay, so A is less than 4. Do I switch signs here? No, we don't. We divide by 3, which is a positive number. All right, so now let's see here. A is less than negative 5, open. And A is less than 4, open. Oh, the negative 5, does it point to the left?
Yeah.
Yeah. How about the 4?
Yeah.
Okay.
So then negative 11 and negative 5. And negative 10 and negative 5.
Right. So, and then you remember, oh, this is n. What does n mean? 2 lines. So, which points have 2 lines on top? Not this one, right? Not that one. How about this one? Yeah, so it's this one. So it's this one here, and then this one here, and then this one is everything here. So what is my solution? Negative infinity. Yes, -5 parentheses. Yes? Okay. So basically it's just whichever one has 2 lines on top. Now, number 5. So 6, oh, you add 1 both sides, so what happened here? 7 is greater than 2a, divide by 2. 7 over 2 is 3.5, right? Greater than a. What does it mean 3.5 is greater than a? A is less than 3.5, okay. Now let's do the same thing to the other one. So keep the -3a by itself, and then bring the 2 to the other side, so what do I have? -6. So we will divide both sides by -3. And do I switch the sign? Yes. So A on the right, and here is 2. What does it mean 2 is greater than or equal to A? Okay. Good. Are we okay so far? All right. So, so we're going to graph 3.5, open, and the arrow point to the left. 2, open or close? Close. And the arrow points to the, where's my arrow? To the left. All right. So now we see, oh, and. What does and mean? 2 lines? So which point have 2 lines? Right. Okay, good. Good job. -infinity to 2. Bracket. Yay or nay? Yep. Okay, are we good? Okay. Now, so this is not bad as long as what? You remember that and means 2 lines. Yeah, you have 2 inequalities with and, so it means you need to have 2 lines on top. It doesn't matter where the arrow points or where the arrow goes, you need 2 lines. What if there is no 2 lines? So for example, if you have something like this and something like this, there is no solution. Yeah, so it needs 2 lines. Yeah, if I have something pointing to the right here and pointing to the left, and then you have and, any points have 2 lines on top? No, so there is no solution. Yay, me? Okay. Now, the other thing that relates to and is called compound inequalities. So it looks like this. So B, compound inequalities. So it has 3 sides. So for example, it has, it looks something like this. -2 less than or equal to x plus 7 is less than 5. Okay. Now, this is a compound inequality. What does it do? Means -2 is less than or equal to x and x plus 7. Sorry. And x plus 7 is less than 5. But are we going to split it? Split it? No, we're going to work all those three sides at the same time. Because I only have x in the middle, so I could do it. If I have x's on all sides, then I have to split it. Yeah. So this is how we're going to work on it. So for example, Negative 2 is less than x plus 7 is less than 5. How do I solve for x in the middle? Subtract 7. Where should I do it? From all the sides, not just the back side and the front side, but from all the sides. So if I'm subtracting 7, I have to do it through all sides. So what is this? Negative 2 minus 7 is negative 9, and this is negative 2. So notice that I'm doing them at the same time. Yeah, I'm not splitting them up. Yeah. So then, when we draw, okay, negative 9 close, right? Negative 2, open. And what about x? X is in between. So I don't have any arrow. It just says that x is in between negative 9 and negative 2. Yeah? So that's my solution. What is my solution? Negative 9, comma, negative 2, parentheses. Right? Okay, do you have to split it up? No, because you only have x on one side. Yeah? But if you have x on several sides, you have to split it up. So maybe let's write down, there's no need to split up the equation if only one expression contains x, the variable. Yeah. If you have only one expression containing x, we don't have to split it up. But if you have something like this, then it's a different story. Okay? So suppose I have x minus 3 is less than 2x plus 1 is less than or equal to 3x. This you have to split up. Yeah, because you have a lot of x's here, more than one x's. So I'm going to write here, note, split, because there are more expressions containing all right, so you're going to split it up. How do I split it up? Okay, and then what word do I use? And 2x plus 1. All right. So you have to split it up this way, and then you can solve, right? Okay. Can you try it? So who's not here today? I think Brandon. Okay. Well, okay, I won't call attendance today, but tomorrow I will. Okay, so what do I do to my x? Bring it to the left, so minus 2x. What do I do to my negative 3? Move it, so it becomes 3. Okay. So x minus 2x less than 4. Right? So now what? Divide by negative 1. So do I switch the sign? Okay. Good. X is greater than negative 4. Okay, what about this? Let's put the x on the left. Well, actually, it doesn't matter, and then we can just switch it later. Put the x on the right. So this is 3x minus 2x, right? So 1 is less than or equal to x. What does it mean 1 is less than or equal to x? Yes. So negative 4, open or close? Open. The arrow points to the right. 1, open or close? Close. And the arrow points to the right. So I could make it higher or shorter. It doesn't matter. So I could make it like this, or I could make it higher. It doesn't matter. As long as they're not on the same level. Yeah. Now, let's look at n. What does n mean? 2 lines. So, where are the points that contains 2 lines? Yes. So, yes, 2 lines on top, right? So my solution is 1 through infinity. Easy? Okay. So now question, when do I split up the compound inequalities and when do I not split up? Yes, so x's are more than one side. Yeah. If not, then you don't. Yeah. Now this is incorrect. So let me show you. Let me say. So suppose I have x is less. So you can never say this. X greater than negative 3 is greater than x, but less than negative 5. Can you write this inequality? No. Inequalities have to be the same. What do I call it? Either less than, strictly less than on both, or greater than on both. You cannot have mixed signs like this. Yeah. So this is yes. So it has to be the same direction, either this or right on both. What else is incorrect? Can I say something like this? Negative 2 is greater than or equal to x plus 7 is greater than 5. Why is it incorrect? Well, because how can negative 2 be greater than 5? Right? So that's why it is incorrect. Does that make sense? Okay, so pay attention to this. I do not want to see mixed signs in compound inequalities, so they all have to go to the same direction. It doesn't matter one is less than or greater equal to, less than or equal to, but one cannot point this way, the other one point the other way. So it has to be the same point to the same way, same direction. Yes? Okay, so I'm going to write these incorrect compound inequalities. So incorrect compound inequality. Alright, so this is one. Mixed sign. The second one is not true. Negative 2 is not greater than 5. Yeah. So this is mixed sign. And this is also a false statement. Negative 2 is not greater than 5. All right. We okay? So now I'm going to talk about OR. Yeah. I'm going to talk about OR. All right. Are we ready? So OR is union. Yeah. So OR is union. So C. Ready? All right. So C, union offset. So it is A, this is the symbol of union, union B. So we use this, the union. And the keyword here is OR. For math, we use OR. What is A union B? So the union of two sets, A and B, okay, this is denoted as A union B, is the collection of elements belonging to A or B. All right. So it's belonging to A or B. So I'm going to use my A and B from the previous one. What is the first 5 counting numbers again?
1, 2, 3.
Yes. So when you count, you start with 1, right? So 0 is not included. What about the first 5 prime numbers?
2, 3, 5, 7.
Yes, 11. I was just in right 9, but that's not true. So we're going to draw the Venn diagram again, and it has intersection. So, okay. All right. So this is your A, this is your B, this is what's common. What's the intersection? 2, 3, 5. Okay, and then in A you'll have 1 and 4, and this has 7 and 11. So which one is A union B? No, that's A intersection B. Yeah, this is before it was N, it has to be belonging to both A and B. This one is belonging to A or B. So it belongs to A or B. Which one belongs to A or B? Which one belongs to A or B? Does one belong to A? Does belong to A or B? Does 1 belong to A? Yes. Does 2 belong to A? Yes. Does 3 belong to A? Yes. So yeah, they're on the set. So this is 1, 2, 3, 4, 5, 7, 11. So that is A union B. So they belong either to A or B or both. Yeah. So the union is everything here. All right. So this is the union. Yes. So this is an OR. It's an OR. So A or B. Yeah, it means everything. Now later on, mathematically, OR means at least one line on top. At least one. Can it be 2? Yes. So it needs to be at least 1. Yeah, like 2 belongs to at least A. Yeah, and also on B. So either belong to A or B or both. Yeah. All right. So let's do an example. So we want to solve graph and write the solution in interval notation. So number one, x is greater than or equal to 5, or negative x is greater than or equal to 4. Number two, x plus 5 is less than negative 3, or x plus 5 is greater than or equal to 3. Alright, so let's do this one first. This is simple. Okay, so number one, let's see. Oh, here we have to change this to x. How do I change this to x? Divide by negative 1. So we switch the sign. Okay. X is less than or equal to negative 4. Yes. So we have to switch the sign. All right, so 5. Open or close? Close. The arrow is to the right. Negative 4. Close. And the arrow is to the left. Okay. So what does OR mean? At least one line. So let me write it here. Which points have at least one line on top? So this one? Yes. So those points have at least one line on top. So this is the way we write it. Negative infinity to negative 4 bracket union bracket 5 to infinity. Yes? Easy? How about the other one? X is less than what? X is less than what? Negative 8. Okay. So this is x is greater than or equal to negative 1. Okay. This is simple also. So we have negative 8 to the left, negative 1 to the right. All right. Good. What does OR mean? At least one line. So which ones have at least one line? Negative infinity to negative 8, negative 1 to infinity. Are we okay so far? Okay. This one, anybody need clarification? No, this is very simple, right? Okay. Now, let me give you more. Number 3. Okay. What about if I have this? Before I put this as n. 6 is greater than 2a minus 1. Now this is changed to or. Or negative 4 is less than or equal to negative 3a plus 2. Okay? And then number 4, we have, okay, I'm just going to hide it. My throat hurts. Move it. Something like okay. All right. So 9.2 is due tomorrow night, right? Yeah. Only 9.2. One section. Okay, so please try it. Sometimes they use function too, so. Yes, is less than 5. No, here is given to 7. So let's do the 4 problems, and then I think we're done. Yeah, with this section. So sometimes they use function notation also. Okay, let me look at that.
This is what only. Can be what? Can be 1 or 2, right? So which one is that? Which one is that? All these ones are at least 1. So 1 and 8 is 0. What was the answer for number 3?
It's 3.5 and 2.
So which ones have at least one line? What does at least one mean?
So it has 2.
Sometimes it can have 2. Sometimes it has 1. So let's do number 3. Yeah. So what would you do here? So bring the 1 to the other side. Okay. So you have 7, right? 7 is greater than 2a. Then divide by 2. So what is 7 divided by 2? 3.5 is greater than a, which means, okay, good. Now, how about the other one? Bring the 2 to the other side, it becomes -2. So, yeah, -6 less than or equal to -3a, then divide by -3, so you have to switch the sign. 2. What does this mean, 2 greater than or equal to a? Okay, so everybody okay with this? Okay. So now, this is a matter of interpreting your OR, right? And that's very important. That's what we're doing here in this section, interpreting AND versus OR. So 3.5, open, and the arrow is to the left, yes. And then 2, what about 2? Open also, oh no, close, right? And the arrow is to the left. Okay. Now it doesn't matter the arrow from the 2 is taller or higher, as long as they're different heights. Now, be careful here. What does OR mean? At least one line. Right? We wrote that many times. So now pay attention. Which points have at least one line on top? Okay. What else? That's it? Well, at least 1. Can it be 2? When I say at least 1, can it be 2? Okay, so it's everything here, right? Right? At least 1 can be either 1 or 2. So your solution is everything here, and what is that? Negative infinity all the way to 3.5. Does that make sense? So at least one line can either be 1 or 2. So you have one interval here. Yeah. Okay. So far so good? Okay. Good. Now the next one. So this is -2c is less than. What happens to this 2? We bring it to the other side, becomes -2. So -4 minus 2? -6. Alright. Now divide both sides by -2, so we have to switch the sign, so c is greater than 3. Alright. How about the other one? -2c is less than or equal to negative. Right. Divide both sides by -2. C is greater than or equal to 5. Yes. Okay. So now let's graph again. Okay, so 3, open. And the arrow is to the right. 5, close, open. Close. And the arrow is to the right. Okay. Okay, so now what's the word in the middle? Or. What does or mean? What does it mean, at least 1? So it means you can have 1 or okay. So which points have 1 or 2 lines on top? Yes. So this is 3, all the way to infinity. Do you know why I don't split the interval? Do I have to split it? No, this is just one interval, one big interval. So I'm not going to say 3 to 5 union 5 to infinity, no, because I don't have to split it. This is just a one big interval. Does that make sense? Okay, all right. Now, number 5. Yes. 8 minus 5 is 3. Okay, and then divide both sides by, yes. Yes. Yeah, we switch the sign here. So A is greater than or equal to -1. Okay. Yes. Okay. Are we okay so far? So the most important is to understand or and, yeah. Okay, so -1, close, and the arrow points to the, okay. So 3, open, and the arrow points to the right also. Good. So now we look at the middle term, which is or. What does or mean? At least one line. Yeah, so which one? Either 1 or 2 lines, so it is all the way to infinity. So -1 all the way to infinity. All right. Doable? Yeah, okay. Good. So number 6, what do you think we'll do? This is very simple also. Yeah, that's it. So you're going to write this 3x minus 5 is less than 5. Or 3x minus 5 is greater than or equal to 7. So you substitute for g of x. Do you think you can continue?
Yeah.
Yeah, okay. So 3x is less than 10. X is less than 3.33333, or you can just leave it as 10 over 3, yes. So here 3x is greater than or equal to, so x is greater than or equal to, yes. That's it, you're done, right? And then this is or. Okay, 10 over 3. Open. Right. 4. Close. There. So I always put them different heights. And then or. What does or mean? At least one line. So which points have at least one line? Here. Yeah. So this one, how many intervals do we have? 2. So that's why you split it. -infinity, comma, 10 over 3, union, 4, comma, infinity. So you know why we use union now, right? Why? You have 2 different intervals. Yeah. When you just have 1, we don't need union. Okay? Are we okay so far? Okay. All right. So I have 5 minutes. I think I'll just let you guys go early because we're done. So yes, Johnny. Okay. Sure. So we go back to compound inequality. Good question. What is it? If you have only one x on one side, then you don't split it. You can't have it, right? If you're not never going to have it. So for example, x plus 2 less than 3 less than 5. This is, we never write something like this also. Yeah. So if it is one side, then for sure it's going to be in the middle. Yeah. Okay. Yes. Good question. Did you guys listen? Did you guys hear what Johnny asked? What did he ask? So he said that what happens if you know when you have compound inequality, and then your x is on the left or on the right, but the answer is we usually never write compound inequality with x is on the left, right, like this. Yeah. So if we only have one side, then it will be where? In the middle. Yeah. So we never write it like this. Okay? Yeah. Good. So if it's only one side, we don't split, and it's usually in the middle. Okay, guys. What homework do you on Wednesday? 9.2 only. Yeah. Tomorrow, make sure you guys show up because I'm going to discuss inequalities using absolute value, and most students find it difficult. But if you show up, I'm very sure you'll get it by the time you leave. Okay? Yeah. All right. So have a good one. Yes. Sure. You're a fixer, right?
Yes.
Yeah.
Because right here, when this dash and this was it because there was an or?
Okay, wait. This is not how we answer this, is it?
No, because this is C. This is where we start C.
Okay.
This is where we start or.
Okay. And
we're
this
gonna use
one?
or. So I'm guessing because we
This
use
is n. No.
Yeah.
Whenever you have compound inequality, it's an n.
Okay.
So you have to write an n here. Now, what does n mean? 2 lines.
2 lines.
So n is 2 lines, or is at least 1 line.
Mm-hmm.
So when you have 2 lines, which points have 2 lines on top? Only this one. Right, so this is this one.
Okay. So this one.
This is an n.
Yeah.
Okay.
This is 1 line. So that's one.
Okay. Now, this is an or.
Mm-hmm.
What does or mean?
1 line.
No. At least 1 line.
Okay.
Not 1 line. It has at least 1. What do we mean by at least 1? Either 1 or 2,
Mm-hmm.
right? So which point have 1 or 2 lines on top of them?
Oh,
Right. From here all the way here. Is it clear?
yeah, I get it now.
Okay. So n means exactly 2 lines. Exactly 2 lines. Or means either 1 line
Or 2.
or 2. Because it says at least 1. At least 1 means either 1 or 2. Yeah?
Yeah, I get it.
You get it?
Yeah.
Okay. Thank you. Okay, so let's see. Okay, so we're done with 9.2. We're done with intersections, unions, and compound inequalities. So let me stop the recording.